All right, here's problem number 3. Problem number 3 says, using the unit normal table, find the proportion under the standard normal curve that lies between each of the following. Okay, so that lies between each of the following. So you've got 5 of those. So I've set it up the same as I had done the others, where for each one I want to look at, I have between two values, the mean has z value of 0 still. Okay. All right. So the first one that we run up against, it says the mean and z are 0. Okay. Again, this is the trick question. The mean has a z value of 0. So the proportion is, there is no proportion. They're the same. Okay. So then the next one, B, says on here, 3B is the mean and the z of 1.96. Okay, we've already done this before, really. 1.96, okay? We're looking for this area here, okay? And so we go back to here. Okay. 1.96, okay? And now this time we're looking for this, the area between mean and z of 1.96, so we're going to have 0.4750. Okay, so 1.96 is 0.40500. All right, and in this case, it's just 40.5%. Okay. And then the next one asks us between the z of a negative 1.5 and a positive 1.5. All right, so on this one, okay, let me move this back up a little bit. All right, on this one, okay, what we're looking for is this area. What is this percentage? Okay, so you're going to find this percentage between the mean and negative, and the mean and positive. So the area is going to be the same, okay? It doesn't matter. You just have to keep straight which is which in terms of that you have to add them. So you have to know the area you're looking for. All right, so if it's negative 1.5 or positive 1.5, the area between the mean and 1.5 is 0.43319, okay? So 0.43319, and that's the same on the other side, right? Because it's still going to 1.5. So the area is 0.43319, okay? So to me, this is going to be 43.32, 43.32, and we're going to add those together, okay? So, oops, what did I do with the calculator? Hold on. All right, so get your calculator out, and then you're going to add these two together. So 43.32 is 86.64. Okay, so this is 86.64 is your answer for that, part C. All right, so then D says 3D is between negative 0.30 and negative 0.10. So what you're looking for in this problem is this tiny little sliver of an area here. All right, so this was a little bit more tricky. It's like we did before, where we're going to get the whole value from here to there, and then we'll subtract out this piece. All right, so the whole value of mean to z for negative 0.30, okay? Mean to z of negative 0.30. So you get your chart and you find on here between the area, so the area between the mean and z, and we're looking at 0.30, so it's going to be here it is, 0.11791. Okay, so 0.11791, okay, is this area here. Okay, then this space here is between the mean and 0.1, and so that is, the mean and 0.1 is 0.03983, 0.03983, or 3.98%, okay? So, and this is 11.79%. So the answer to our question, let's just put it up over here, 11.79 minus 3.98, okay? 11.79 minus 3.98 is 7.81%, okay? So the answer to 3D is 7.81%. Then our E, okay, it asked for positive 1 and positive 2. So in this particular case, between the mean and positive 1, we're going to do exactly what we did up here. So in this case, we'll get the whole thing between the mean and 2. Okay. So between the mean and 2, between the mean and 2.0 is 0.47725. 0.47725. Okay, so 0.47725 is this whole value. Now we need this value. It's between the mean and 1, okay? The total of mean to 1. So this is going to go back over here, and between the mean and 1, right, is our 0.34134. 0.34134. So 34.13%. Our total amounts to 47, so do what we did before. 47, we'll say the 725, so 47.73. 47.73 minus 34.13. And this should be very close to 14, right? Because that's what we said, 34.14. So 47.73 minus 34.13 equals 13.6. Okay, 13.60. And that's the exact part. So when I tell you, say it's 14, that just gives us an estimate. But the exact math for the difference between 1 and 2 is actually 13.60. Okay, so that is problem number 3.